Welcome to today's lesson on 8.5F. I can distinguish between proportional and non-proportional situations from tables and equations in the form of y equals kx or y equals mx plus b. So if we remember, y equals kx is for proportional relationships and y equals mx plus b is for non-proportional relationships. Then the essential question is, what is the difference between the tables of y equals kx and y equals mx plus b? So for y equals kx, because it's proportional, we know it goes to the origin. So that means that the table would include that 0, 0 point or the origin point. And for y equals mx plus b, we know it has a y-intercept, which is the b right here. So we know that, let's say if our x value is 0, our y is 6, that means our y-intercept would be 6. Okay, so we have some vocabulary words. The first one is linear equation. So the definition for that is an equation between two variables that is a straight line when graphed. And if you look at the picture here, you can see that for both proportional and non-proportional relationships, they are both linear because they both make straight lines when graphed. Okay, the next vocabulary word is constant of proportionality. So the definition for that is the constant ratio of one variable to another that is proportional. So if we remember, the constant of proportionality can be found by dividing our y divided by x. And we use the letter k to represent constant of proportionality. So k is equal to y over x. And then for proportional relationship, the definition is relationships between two variables where their ratios are equivalent. One variable is always a constant value times the other. Okay, so the form for the proportional relationship, which we just went over in our lesson target, is y is equal to kx. Then for non-proportional relationship, the definition is relationships between two variables where their ratios are different and the line does not pass through the origin. So that equation, again, we also went over, is y equals mx plus b. And finally, the vocabulary word is y-intercept, the point where a line intersects or goes through the y-axis. And the y-intercept in our non-proportional relationship equation is this b. And so looking at this visual for proportional relationship, we've learned about direct variation. We know that direct variation is also the equation y is equal to kx, which is y is proportional. And instead of calling it constant of proportionality, that letter k, they call the k constant of variation. So it's just the same thing, they're synonyms. And you can see examples of proportional equations are y equals negative 7x, y is equal to 0.5x. And then we are given some tables, right? These tables don't have the origin in them. They don't have that 0, 0. But if we divide y divided by x, 14 divided by 1 is 14. 28 divided by 2 is 14. And lastly, 42 divided by 3 is 14. So that means our constant of proportionality is 14 for that table. Then for this other table, if we divided 40 divided by 5, we get 8. Then if we divide 72 divided by 9, we get 8. And lastly, if we divide 176 divided by 22, we get 8. So the constant of proportionality or constant of variation for this table would be 8. And then looking on the right side for non-proportional relationships, you can see that some examples of equations are y is equal to negative 9x plus 0.5, y is equal to 3x plus 8, y is equal to 1/4 x minus 4, y is equal to 2/3 x minus 4. And then you can also see that this top one has a negative y-intercept, this top graph, and then this bottom graph has a positive y-intercept. We also have some tables here, and it doesn't tell us what our y value is when our x value is 0, but if we even try to divide our y divided by x, you're going to see that the answers are not the same, right? So 4 divided by 1 is 4, but 6 divided by 2 is 3. So that's why this is non-proportional. And we, for non-proportional relationships, use the equation y2 minus y1 over x2 minus x1 to find our slope. So in the classroom, I have these two anchor charts, proportional relationships on the left, non-proportional relationships on the right, and you can see the different forms, right? Which we've all learned about and talked about, which is equations, tables, graphs. Okay, so now we have this turn and talk with a partner. So for this problem, you guys should be thinking about what vocabulary words go under proportional relationship, what vocabulary words go under non-proportional, as well as what goes for both, right? So that's how we read this Venn diagram. So we have to categorize the following words and equations into the Venn diagram. So the first word is y-intercept. So I know that only non-proportional relationships have a y-intercept. Then we have origin. So I know that only proportional relationships are lines that go through the origin. Slope is a word that we use for non-proportional relationship, and we use the letter M to represent slope. Then for constant of proportionality, which is very similar to slope, we use constant of proportionality. We use the letter K to represent that. And that goes under proportional relationships. And then we have linear equation. So both proportional and non-proportional relationships are linear equations. They both make straight lines when you graph them. So this is going to go in the middle. And then rate of change works for both slope and constant of proportionality. It's a synonym. It means the same thing. So we're actually going to write rate of change in the middle as well. Because rate of change just means your change of y over your change of x. And for slope, if we remind ourselves, the slope formula is y2 minus y1 over x2 minus x1. The constant of proportionality formula is y over x. You can see that the rate of change is just that change of y on top divided by our change of x on bottom. Okay, so then lastly, we have our equations. Y equals mx plus b is for non-proportional. And then y is equal to kx is for proportional. Then we also have this anchor chart in the classroom to solve for the slope as well as to solve for the y-intercept. And now we're going to go into our activity for today. So for activity, it reads, you have discovered that the equation y is equal to mx represents a proportional relationship. The equation represents every point x comma y on the graph of a line with a slope m that passes through the origin 0, 0. So I just want to clarify that even though they use the y is equal to mx equation, we know that that's the same thing as what we've been talking about for y is equal to kx, right? They just used m to represent the k, but we know that m and k are both the rate of change. Okay, so the second part of that reads, an equation of the form y equals mx plus b, where b is not equal to 0, represents a non-proportional relationship. This equation represents every point x comma y on the graph of a line with slope m that passes through the point 0, b. Okay, so that's, of course, information that we already know and we've talked about for non-proportional relationships. So now for 1 and the first bullet point, it says, consider each graph shown to determine whether the graph represents a proportional or non-proportional relationship. So looking at this graph of fruit delivery, the number of pieces of fruit and the cost, we can see that it is going to be non-proportional. And the reason that it is non-proportional is because it has a y-intercept. The line does not go through the origin, right? It goes through this number 20 right here. Okay, so then the second part of the question is to write an equation in the form y equals kx or y equals mx plus b to represent the relationship between the independent and dependent quantities. So since this is a non-proportional relationship, we're going to use the form y is equal to mx plus b. And to start solving this graph or to solve for the slope, we have to make a table. And we have to choose at least 2 points because with the table, we need at minimum 2 points. So I'm going to use that y-intercept, that 0, 20. And then I'm going to also use this point right here. So this looks like 60 and 28. If I wanted to, I could also use this last point up here, which looks like 120 and 36. But that's just an option if you didn't want to use one of the other 2 points. Okay, so from here, because I know it's non-proportional, I know I have to find my slope. So I'm going to write my equation to find the slope, which is y2 minus y1 over x2 minus x1. And to solve for the slope, I'm going to have to label this table. So the 0 is going to be my x1, the 20 is going to be my y1, the 60 is going to be my x2, the 28 is going to be my y2. And so for here, I'm going to plug in the y2 minus y1. So I'm plugging in the 28 minus the 20, and then the 60 minus the 0. So now I have some subtraction and some division to do. So 28 minus 20 is 8. 60 minus 0 is 60. So I have 8 over 60. So technically that is my slope, but I do want to write it in simplest form since I am going to be keeping this as a fraction. So to do that, I have to think of my factors of 8 and 60, or the numbers that multiply together to make 8 and 60. So for 8, I know that 2 times 4 makes 8. So 2 is a prime number, so that's the smallest possible number it can be broken down into. So then I have 2 times 4 can be broken down into 2 times 2. So that's how I get 2 times 2 times 2 makes 8. And then for 60, there's multiple factors of 60. I'm going to go with 12 times 5. So 5 is a prime number, so that's the smallest number it can be broken into, but 12 is not, right? So 12 can be broken down into 3 times 4. So then I have 3 times 4 can be broken down into 2 times 2. So now I have the prime factors of both 8 and 60, and I'm going to cross out the numbers that are the same on top and bottom. So I'm going to cross out the 2 and then another 2. And then from here, on top, I'm left with 2. On bottom, I have 5 times 3, which is 15. So then that means that my slope is m is equal to 2 over 15. So I'm going to circle that because I'm going to need that for my equation. So we have y is equal to, I know my m, so that's the 2 over 15x plus, when we have a graph, we can actually visually see what the y-intercept is. So we actually don't have to work backwards plugging in a point, an x and a y value to solve for the b. So in this case, I see that my y-intercept is 20, so I'm just going to write that into my equation. We have y is equal to 2 over 15x plus 20. Now I'm going to go into Desmos just to double check my answer. So on Desmos, I'm going to make the table. So to do that, I'm going to go to the plus table, and then I'm going to type in my two numbers, right? So I have the 0, and then I have the 20, and then I also have the 60 and the 28. So from here, I have to type in a variation of that y equals mx plus b equation. So you can see up here that I don't have just y, I have y1. So that's why I need to use y1. And I can't type in equal to because I don't actually know, like I'm working backwards to solve. So I'm going to type in the tilde. And then we have m x1, because again, in this table, we don't just have x, we have x1 plus b. Okay, so from here, you can see that m is 0.133, b is 20, right? So we already know that our y-intercept or our b is 20. To figure out if our slope, which was the 2 over 15, is equivalent, we're going to go ahead and divide 2 divided by 15. And you can see that 0.133333, which matches our slope right here of m is equal to 0.1333. Okay, so then we have question number 2. Consider each graph shown. Determine whether the graph represents a proportional or non-proportional relationship. So this graph right here is proportional. And it's proportional because it goes to the origin. And we have to write an equation in the form of y equals kx or y equals mx plus b to represent the relationship between the independent and dependent quantities. So because we know that it's proportional, we know that we're going to write the equation in the form of y equals kx. So we're going to go ahead and solve for k. And if you guys remember from earlier, as we're going over the vocabulary, k is equal to y over x. So we're going to choose 1 point. So for proportional relationships, we only need 1 point. So I see this one right here, and my x value is in between 2 and 3, so that's going to be 2.5. And then my y value is 160. So I have 2.5 comma 160. So from here, I'm going to go ahead and label my 2.5 my x, my 160 my y. Okay, so now I have to plug that in. So I have my y is 160, my x is 2.5. If I go ahead and divide 160 divided by 2.5, I get 64. So I know that my constant of proportionality is 64. So now when I go ahead and write my equation, I'm going to write y is equal to 64x. Okay, next, for number 3, it says determine the slope of this graph. And then we have to write an equation to represent it. So I see that this is a horizontal line. I can make a table and input the points. So I'm going to choose 2 points on this line. So I'm going to choose 2, 5, and then 4, 5. So I'm not going to delete this equation y1 tilde mx1 plus b, but I am going to change the numbers in this table. So we have 2, 5, 4, 5. And you can see that our slope is 0 here. So that means that m is 0 right here. And then, since this is a non-proportional relationship, it has a y-intercept of 5, we're using the form y is equal to mx plus b to go ahead and solve it. So we know that our slope is 0, so our equation is y is equal to 0x plus 5. And we can actually further simplify this equation because we know that 0 times any number is always going to be 0. So we can just write it as y is equal to 5. So our answer is y is equal to 5 is our equation for this horizontal line, and our slope is 0. So anytime you have a horizontal line, which is a straight line from left to right, our slope is always going to be 0. And really quickly, I want to go over how we could have solved this road trip graph, this proportional relationship graph on Desmos. Okay, so we have one of our points, which was 2.5 and 160. And it's very similar to how we solved the previous problem. Now we have to find another point because we need 2 points at least when we make a table. So I found another one right here. It looks to be 5 and 320. So I'm just going to go ahead and change the numbers in the table. Again, I don't have to touch the equation because I'm going to be using it over and over. And then here, I can see that my m, or my slope, is 64. So that matches what we found up here. M is 64. And then if we look at our y-intercepts, b is equal to 0. So anytime b is equal to 0, that means that this is a proportional relationship. So if our y-intercept is 0, it goes to the origin, it's proportional. Okay, so now we're going to go into our we-do. We have to write a linear equation to represent the relationship, and we have to determine whether the table represents a proportional or non-proportional relationship. So when we have a table and it doesn't give us what our x value or what our y value is when our x value is 0, we can't easily identify if it's proportional or non-proportional. So we're going to assume it's non-proportional. So to do that, of course, we're going to have to find our m. And our equation for our m is this y2 minus y1 over x2 minus x1. Then we need to choose 2 points, and we're going to label them. So we're going to choose the 230 and then the 890. So I'm going to label the 2 my x1. It's my first x coordinate. And then my 30 is my y1. It's my first y coordinate. So remember, all the numbers on the left side of the table are our x's. All the numbers on the right side of our table are our y's. And the 8 is going to be our x2. And then the 90 is going to be our y2. So now, of course, all we do is plug in the numbers into this equation right here. So we have y2 minus y1. So we have the 90 minus the 30. And then next we have x2 minus x1. So we have 8 minus 2. So when we do that, we have 90 minus 30, which is 60. 8 minus 2, which is 6. And lastly, we have 60 divided by 6. That's 10. So that means that my slope is 10. So I'm going to use that to start to write my equation. So I have y is equal to 10x, but I don't know what my b is, right? So I'm going to have to work backwards to solve for that. So I'm going to rewrite my equation up here. Y is equal to 10x plus b. And to solve for b, I need to know my at least one x and one y value. So I'm going to go ahead and choose this first x and y value that we worked with. Okay, so I'm going to plug in the y value, which is 30. So we have 30 is equal to 10 times our x value is 2 plus b. So next, I'm going to go ahead and solve this. So we have 30 is equal to 10 times 2 is 20, 20 plus b. And then the last step is going to be to move the 20 to the other side. So I'm going to do that by subtracting 20 on both sides. So now we have 20 minus 20, which is a 0 pair. So we have b is equal to 30 minus 20, which is 10. So now I have both my slope and my y-intercept. So my equation is going to be y is equal to 10x plus 10. And because this is my equation, I know that this is a non-proportional relationship. Because again, non-proportional relationships have a y-intercept. Okay, my next redo is super easy. I have to determine whether the equation represents a proportional or non-proportional relationship. So we have the equation y is equal to 3x plus 0. So I see that it has a plus 0, but I see that, or I remember that when my y-intercept is 0, that means it's going through the origin. So that makes this relationship or this equation proportional. The rest of the worksheets or the rest of the lesson is you-dos as well as independent practices. And then we have a DOL at the end. Thank you so much for following along in today's lesson and see you in the next one.